The basic thing that you study in calculus is a function. And so the purpose of this video is to introduce the concept of a function. So to think of it in the abstract sense, but then also in the real world sense, what is a function? So that's what we're going to take a look at today. So what is a function? How is it defined? And what can we do with it? So the first thing here is the technical definition of what a function does. A function is something that maps an input from its domain into an output in its range. So we have some key terminology here that's important to know when talking about functions. So the picture on the upper left illustrates the function process. You have an input, it goes into the function, and then you have some sort of output. When we're representing things algebraically, the input is usually called x, but it could be called any variable, and the output is usually called f of x. So f and then in parentheses x. So the input goes in parentheses, and then the output is what you get from the function. And usually we would say that's some like y value that comes out. So often you write the function as f of x equals y. The picture in the bottom right is showing you what those other two words in that definition mean, domain and range. So the domain is the set of all the possible inputs that you can insert into the function. So in this case, the domain is the numbers 1, 2, 3, and 4. Then the function will take you over to another space of numbers called the range. And the range are all the possible values you can get out from whatever you can put in the function. So if you put 1, you get a 6. If you put in a 2, you get a 4. A 3, you get a 2. A 4, you get a 2. So these are all the possible outputs. That's the range of this function, is the numbers 2, 4, and 6. So in an abstract sense, that's all it's required to be a function. You have to have a domain of numbers. Those domain take the numbers in the domain, or the values in the domain, take you to some values in the range. And the function is the machine that sort of does that work. For something to be a function, it does not have to be numerical. It could be any sort of information that maps from an input, a domain, into a range and some sort of output values. And so here we have a ridiculous example. It's positions on a baseball field mapped to fruit. Now each position on the baseball field maps to some type of fruit. Third base becomes grapefruit. You could ask, why? Why are we doing this? This actually came from a comedy podcast that's baseball focused. And as a funny exercise, they thought, what would be the corresponding fruit to each position on the baseball field? Hilarious, really enjoyed it, but at its heart, it's a function. It's a mapping of one input to a different output. And so I show this example just to stress that when you have that relationship, you have a function. For every input, you map to a specific output. Now, a more real-world example is temperature and time of day specifically. On the left, there's a table of information that lists the hours after midnight and then the temperature that it is outside. So that table form is a representation of the function. And then on the right, we have the graphical form, right? We have a graph of temperature and time, and you can see the behavior of it. It's cyclical, right? The temperature rises and falls over the course of the day. And so this temperature function shows us how the temperature corresponds to each time of day. And just as a hint towards talking about types of functions, one thing we'll do is look at the behavior and then try to say, well, what algebraically is that? What is that function? And in this case, we know it's going to be cyclical. And so if you know a little bit about functions, you could say, oh, that's kind of like a sine function. We could map this to a sine function. One thing I have not said, but has been implicit in what I've said, is that the functions lead from an input to an output. Specifically, one output for each input that you put into the function. And we call that type of function a one-to-one function. One input leads to one output. Graphically, you can check that with this vertical line test. So there's two graphs pictured here. The one on the left passes the vertical line test. The lines intersect the function at one point. At that particular x value, there is exactly one y value. On the right, we have a function, not a function, a graph that does not pass the vertical line test. Now, why do we care? Well, the goal of a function is to predict the value of something given an input, predict the output from an input. If you do not pass the vertical line test, then there are multiple outputs for a given input. It's not one-to-one. So which is the output? It's ambiguous. And when you have that ambiguity, we technically do not call that a function. Now, functions will have inverses. Not always, but many functions will have inverses that can take you backwards. So a function takes you from some values x over to some values y. The inverse of that function would take you from whatever the y value is back to the original x. So it's just the reverse mapping, going backwards from the range to the domain. Now, inverses, which is the inverse and which is the function, that depends on your perspective, right? If you have a function that's going from x to y, then its inverse goes from y to x. The domain of one becomes the range of the other. So you could look at that process either way. The point is that functions that have inverses, you can reverse the process. And so that will be an interesting thing to do. We can use inverses in solving equations, and we'll see some of that in the next video.